When he was just 20 years old, Mikhail Shapiro helped to usher in a new age of neurotechnology. He co-founded a startup called Cyberkinetics to develop implantable devices designed to allow quadriplegics to control their environment with just their thoughts. Shapiro is now helping to commercialize new research in neuroscience and other fields as a partner at Third Rock Ventures. He was chosen for this year's TR35 because of his drive to translate novel technologies into real-world applications.
Kind of technologies I'm interested in, and I think over the next decades are going to really transform the way people approach the brain, are technologies that allow us to non-invasively monitor the activity of the brain with things like magnetic resonance imaging or other approaches, nanotechnology, where you can introduce sensors into the brain to extract the activity that's happening there, and then on the other end be able to stimulate activity in the brain. And we've seen a lot of exciting things, optogenetics kind of as a recent example, that may allow you to do that. But really it's ultimately going to be the convergence of those kind of technologies, the delivery, the monitoring, and the stimulation that is going to allow us to better treat diseases and better understand the brain. And that's what I'm excited about.
After graduating from Brown University, Shapiro went on to a doctoral program at MIT with the goal of developing less invasive brain monitoring technology.
I really wanted to develop a new technology for interfacing with the brain that would be non-invasive, so it would be a method like MRI that would allow you to do the imaging. It would act at the molecular level, meaning that it could allow you to sense something like a neurotransmitter, dopamine or serotonin or another one, and something that you could imagine a way in the long term that it would be possible to deliver it to the right part of the brain to be able to image that activity.
Shapiro wanted to develop a non-invasive method of monitoring dopamine, an important chemical messenger in the brain that also plays a role in Parkinson's disease and other disorders. Shapiro decided to use a similar principle to that of functional MRI, which uses a magnet to monitor hemoglobin in the brain as a proxy for brain activity. By selectively mutating a protein derived from bacteria, Shapiro created a molecule that would bind to dopamine. The protein emits a signal that is detectable via fMRI. The signal differs depending on whether it is bound to dopamine or not.
What I hope this means we'll be able to do is to take this protein, encode it as a gene, deliver it to the right cells in the brain where we want this kind of sensing to happen, and have the cells make the sensor for us.
While the technology has only been tested in animals thus far, Shapiro hopes that it can eventually be used in humans using a delivery method similar to that of gene therapy. In the long term, Shapiro hopes to commercialize his non-invasive brain imaging research and other novel neurotechnologies by bringing together the various approaches to studying the brain.